This is problem number 4 from section 7.5. It says use an identity to evaluate the expression sine of 2 sine inverse of negative root 2 over 2. Now I want us to notice that 2 and then this sine inverse is acting like our angle. So this is really sine 2 theta, meaning double angle formula. So if we pull out a double angle formula here, that's how we're going to start this problem. We're going to say that sine 2 theta equals 2 sine theta cosine theta. So this is how we write it. We say that 2, and then we can say that this is sine of sine inverse. Now that's kind of weird to write. Of negative root 2 over 2 times cosine of sine inverse negative root 2 over 2. Now that's kind of weird to write, and this is not the only way to solve this problem. They say use an identity to do it, and obviously they want us to use the double angle formula identity to do this. Okay, so let's finish this out. Now if we go through and we take a look at this sine and sine inverse are opposite each other. They cancel each other out. So we end up with negative root 2 over 2. So we're going to end up with 2 times negative root 2 over 2 times something else that's happening here. So here's how we evaluate this. We say, what's sine inverse of negative root 2 over 2? Well, remember, sine inverse is saying, sine inverse is essentially asking for an output, which is the angle, and the input is the length of the triangle. So if you remember like the sine function, so for a sine function, you have an output, so sine theta, its input would be an angle, and its output is the length, right? Because anytime you like say sine 90, it tells you the length is 1, or sine of 45, it tells you the length is root 2 over 2, which is the length. Sine inverse, remember inverses from chapter 4, remember inverses, the domain and range switch. So the input now is the length, and the output is the angle. So when you see sine inverse of negative root 2 over 2, it's telling you the length. Go find the angle for that length and the angle for sine. So we go to negative root 2 over 2, and sine inverse is only defined in these two areas, which would be quadrant 1 and quadrant 4. So we can look over here and we can say that we can see that obviously negative root 2 over 2 for sine is at 7 pi over 4, or 315 degrees. So we're going to use this 7 pi over 4 radian as our value here. So sine inverse of negative root 2 over 2 is 7 pi over 4 because that's the output angle. So we can write this as cosine of 7 pi over 4. Okay? Now, cosine of 7 pi over 4, we're still just sitting right here. What's cosine at that angle? 7 pi over 4. Well, that's root 2 over 2. So we're going to now replace this with root 2 over 2. So we're going to say 2 times negative root 2 over 2 times root 2 over 2. Let's find out what all that equals. Well, if I take 2 times negative root 2 times times root 2, negative root 2 times root 2 is 2. So I end up with 2 times negative 2. Yeah, 2 times negative 2 on top over 2 times 2 on the bottom. All right, so we have 2 times negative root 2 times root 2 was the negative 2. That ends up being negative 4 over 4, which is negative 1. And so our solution for this problem, although this took kind of a long time, I had to explain some stuff. The solution for this problem is only negative 1, and we found it pretty quickly by using the double angle formula.